are the magic numbers in nuclear physics? The answer is probably going to surprise you. And to explain it, it helps to start off with the chart of the elements. If you look in my chart of the nuclides, in the back is the chart of the elements. And when you look at the chart of the elements, everybody hopefully is familiar with the noble gases. The noble gases, things like helium, radon, krypton, xenon, neon, all of those are noble gases because the outer valence electrons are all in filled shells. So you've got a complete energy level that's completely filled with electrons, and so it's not reactive. It's very stable. It's hard to get an electron off, or it's hard to put an electron on there, and that makes it a noble gas. And when you look at those, they have specific numbers of protons. You might say that there are magic numbers of chemistry. There would be 2, 10, 18, 36, 54, and 86. And you have something with nuclear physics that's very, very analogous. The numbers are different, though. It's 2, 8, 20, 28, 50, and 82. Those are the magic numbers of nuclear physics. And those are the number of nucleons that have extra special bonding. Basically, it's a filled shell of orbitals inside the nucleus. So in the same way that the electrons are orbiting the atom, the nucleons are orbiting that central potential there. Even though it's not a point charge anymore, it's a distributed charge, and you still have the Coulomb repulsion. So you have a lot more physics that's going on. The particles are going to be relativistic, the neutrons and protons. They're going to have the uncertainty principle that they'll have to obey to, but they still have to obey Schrodinger's equation. And so when you look at things like helium, it's like doubly magic. Helium has 2 protons and 2 neutrons, and so it's doubly magic in the sense that 2 is a magic number. And so if you look at helium-4, you see it's the major constituent of helium. Helium-3, that's mainly just caused by tritium production in the atmosphere. The next one, 8, where you have 8 protons and 8 neutrons, that's oxygen-16. That's also the most abundant isotope. If you can see that, the oxygen-16 is doubly magic as well. And so when you have the filled shells of neutrons and protons, you get super stability. It's very hard to remove a nucleon, and it takes a lot more energy than it otherwise would have to put an extra nucleon in there. And so those are the magic numbers of nuclear physics. They're just like the magic numbers of chemistry, but we don't call them magic numbers of chemistry. They're really just the noble gases. And for nuclear physics, we call them the magic numbers. I hope that helps. Thanks for watching. Have a good day. Bye.